Let's start with number properties today. So it is a topic which has some of the simplest concepts, your odd, even, prime numbers, this, that, but some of the trickiest questions. So while doing the question, you're going to be pretty comfortable and you'll feel it's quite easy. Then when you look at the answer, you might be surprised. And when you look at the explanation, you're just going to be frustrated with yourself that how could you miss something so simple? Let's jump in. A number line is a very simple but effective tool in a lot of questions. So we'll ensure that we understand it very well. Let's draw it here. So all real numbers lie on the number line. Here we have 0. Normally we depict positive and negative integers on the number line. But note that all and so on till infinity and till minus infinity on this side. But note that any number, real number that you can think of, it does lie on the number line. So this point is 1.5. Now, somewhere over here, there is a point that represents the exact value of root 2. This will be 1.414, blah, blah, blah. But the exact value will be represented over here at some point. Right? Now, for example, now minus, say, 1/3. Every number that we can think of, rational as well as irrational, it will lie on the number line. X is less than y implies that x is to the left of y. If we are visualizing it on the number line, and if we are given that x is less than y, we can visualize it as this. We don't know where the 0 is. We don't know whether x is to the left of 0, or both are to the left of 0, or both are to the right of 0. It doesn't matter. All we know that relatively speaking, x is to the left of y. And similarly, if we are given that x is greater than y, then we know that x is to the right of y. X is here and y is here. It is to the right. Again, relative to 0, we don't know where they lie. So they could be both negative, both positive, one negative, but we know that x will always be greater than y. So x will always be to the right of y. So what does x minus y greater than 0 imply? That x is greater than y and x is to the right of y on the number line. All right, so how does this help us in questions? Let's take an example to understand that. Now, there are 4 distinct points, P, Q, R, S on the number line. So the distance between P and S is 6. So the distance between P and S is 6. Now, this could be like this, or it could be like this. We don't know which is to the right and which is to the left as of now. The distance between Q and R is 8. So we would have Q here and R here. And this distance would be 8. Or we would have R here and Q here, and this distance would be 8. Again, we don't know which one is to the left, which is to the right. If Q is equidistant from P and S, and P is to the right of R. Okay, so let's draw this where we say Q is equidistant. So Q is in the middle of P and S, and we know distance between P and S is 6. So it is either like this, that the distance between Q and S and between P and Q will be 3 each, because the total distance between P and S is 6, or it will be the flip way. That is, S will be here and P will be here. Of course, the distance between them will be 3 each. Now, if Q is equidistant and P lies to the right of R, so P is to the right of R, so R would be to the left of P. So R would be either here somewhere, or R would be somewhere here, anywhere over here, doesn't matter, yeah? What is the distance between R and S? So we know that R is to the right of, to the left of P. And what we know is that distance between R and Q is 8. So let's say if this were the case, if we were considering this case, then Q is here and R is to the left of Q. So R will be over here and this distance will be 8. Now, of course, R cannot be over here 8 units away. Why? Because then it is going to be the right of P. But we know that it lies to the left. R is to the left of P and P is to the right of R. So that is why it has to be on the left hand side. And if this is the case, then R again is to the left of Q 8 units. So Q is here and R would be somewhere over here. Again, this is going to be 8 units. Now note that R cannot be this side. Again, we cannot have R this side 8 units because then R is going to be to the right of P, which is incorrect. So R will either be here or here. So here the distance between R and P is 5 units. And here the distance between R and P is 8 plus the 3. So a total of 11 units. So what is the distance between R and S? Okay, so between R and S over here, it is 8 plus 3, that is 11. And between R and S over here, the distance is 8 minus 3, which is equal to 5. So the distance could either be 11 or 5, depending on which case it actually is. Either is possible as per the given information to us. So when I read x is less than y, I like to visualize it on a number line that x is to the left of y. It doesn't matter whether they're both to the left of 0 or to the right of 0, or x is to the left and y is to the right of 0. All I know is that on the number line, relative placement is that x is to the left of y and y is to the right of x. We know what the place value of numbers are. So for example, we have 256. This is the units digit, this is the tens digit, and this is the hundreds digit, which means that its place value is 1. So this is 6 into 1. Here, this place value is 10. So this is 5 into 10. And this is hundreds. So this is 2 into 100. And that is how 256 actually represents 200 plus 50 plus 6. And of course, we can do the same things when we have decimals as well. So say if we have 256.17, this is 1/10. The place value is 1 by 10. And the place value here is 1 by 100. So overall, then this number becomes 200 plus 50 plus 6 plus 1 by 10 plus 7 by 100. We know that this is a concept of place value. Now, how is it used in questions? Say, given two 3-digit numbers formed using each of the digits 2, 4, 5, 7, and 9 exactly once. So we cannot use a digit twice. Each digit is used exactly once. We have to make 2 3-digit numbers, and we have 6 digits over here. So that makes sense. 2, 4, 5, 7, 8, and 9. What is the maximum possible difference between the numbers? So we'll make two numbers and we have to find the maximum possible difference between them, which means that one number, say on the number line, one number should be as left as possible and the other number should be as to the right as possible. There should be maximum difference between the numbers. So one number should be as small as possible and the other should be as large as possible. Okay, now, so how should we start? Look, a number that starts with a 2 in its hundreds place is going to be much smaller than a number that starts with a 4 or a 5 or a 7 or an 8 in its hundreds place. And a number that has a 9 in its hundreds place is going to be much greater. This number, the hundreds place, has the maximum weightage, right? This is 100. The weightage given to it is 100, whereas the weightage given to this digit is only 1. So that is why we'll try and use the smallest number in the hundreds place to get the smallest number. And we'll try and use the greatest digit in the hundreds place to get the largest number. So we'll start with 2 in the hundreds place for the smallest number. Let's say this we are trying to write the smallest number possible, and this we are trying to write the greatest number possible with these digits. So we start with the 2. Next, since we want it to be as small as possible, we take 4 in the tens place, 4 and not 5 in the tens place again, because this has more weightage. So a 40 will be smaller than a 50. So we'll stick with 4 in the tens place. And then we have 5 in the units place. Now this number is as small as we can possibly make using these digits, these 6 digits. What about the greatest number possible? We start with a 9, we go on to 8, and we go on to 7 then. Okay, note that we cannot make it, let's say 9, 7, 8. This will not be the greatest number. Why? Because here we have 70 plus 8, because the tens unit is, a tens digit is 7 over here. Whereas here the tens digit is 8, so we already have an 80. So then this 80 will always be greater than the 70 plus 8. So that is why we should take as great a digit as possible in the tens place. So that is why the number that we get is 9, 8, and 7. So now we can just find the difference between these two numbers, and we get what is the maximum possible difference, which is 2, 4, and 7. 742 is the difference between these two. All right. Now, what is the minimum possible difference between the two numbers? So this is done. Let's now find the minimum possible difference, which means that the numbers should be as close as possible on the number line. There should be this minimum difference between them. That means they should be as next to each other as possible. The smaller number should be as great as possible, and the greater number should be as small as possible. We are pushing them towards each other. Okay, now when we want two numbers to be very close to each other, the hundreds place, they should be the consecutive integers, like they should be 4 and 5, or they could be 7 and 8, or they could be 8 and 9. Note that they'll all be right next to each other. We can, if the pair is 2 and 4, this is 200 something and this will be 400 something. So certainly the distance between them will be more than will be the distance between 4 and 500, 400 something and 500 something. They will certainly be closer. Here they have the entire 300s between them, whereas here they don't. So that is why we'll try to stick with numbers which are right next to each other, and we have 3 such pairs. Now, all these 3 pairs as of now are equivalent to us, so we don't really care about which one we pick up for the hundreds digit. Now, next, let's say we start with 4, 5. Next, now we want this 400 number to be as great as possible and the 500 number to be as small as possible. So then if we put a 9 over here, the 90, we get a number 490 something, which is as great a 400 number as we can make with these digits. So let's put 9 over here, and to make this number as small as possible, let's put 2 over here, because 2 is the smallest digit that we have available. So now 490 something and 520 something, they are as close as possible as of now. Now, what are the digits remaining? Now we have 8 and 7 remaining. So since we want this number, a smaller number, to be as great as possible, we'll give 8 to this and we'll give 7 to this to get a difference of 29 between them. All right. It's best to reserve this 9 and 2. Any of these pairs that have a 9 or a 2 should be discarded right now, because 9, it's best to reserve them for our tens digit, because 4, 5 is equivalent to 7, 8, and that is equivalent to 8, 9 in the hundreds place. They're all the same. So then, since here we are using 9 in the hundreds place, let's discard this. Let's not use it. We'll reserve it for the tens place to make that smaller number as great as possible. Okay, so what about this case of 7 and 8? Again, we'll make the smaller number as great as possible. So let's put 9 over here and let's put 2 over here to make this number as small as possible. Now we're left with 4 and 5. So the 5 goes here and the 4 goes here. And the difference between them is again 29, which should not be surprising, because finally the numbers were equivalent. 4, 5 is equivalent to 7, 8. And we have used 9 and 2 in the tens place, the greatest available digit and the smallest available digit, to make them as close as possible. So then both of these are equivalent, and the minimum possible difference between the two numbers will be 29. Now let's look at the concept of appearance of digits. Let's write down, let's say, I write down 100, 101, 102, 103. I write down all the 3-digit numbers that we have. So here then we'll have 200 somewhere, 201, 202. Then we'll have somewhere down the line 210, then 211, and so on and so forth. Then we'll have 300, and on and on and on till 999. These will be all our 3-digit numbers. Now, notice how the units digit changes here. This is the units digit, this is the tens digit, and this is the hundreds digit. So notice how the units digit changes from, it goes from 0 to 9 here when we get 109 just before 110, right? So then these are all the 10 digits, they appear from 0 to 9. After this, we get 110, and again 110, 111, 112 until 119. We again get all the 10 digits from 0 to 9 in the units digits. So if we were to just look at the hundreds digits, so on and so forth till 110, okay, let's write 109 till 111, 112, so on and so forth till 119, then 120, so on and so forth till we go to 199. What will we find? In these 100 digits, from 100 to 199, we have 100 digits. So we'll have 10 digits from 0 to 9, then again 10 from 0 to 9, then again 10 from 0 to 9, and this will be repeated 10 times. So in the units digit, each digit will appear 10 times. All right, how about the tens digit? What happens first? In the first 10 numbers, we have 0 in the tens place. In the next 10 numbers, we have 1 in the tens place. In the next 10 numbers, we have 2 in the tens place. So in the tens place as well, it appears 10 times. In the units place also, each digit appears 10 times. And in the tens place also, each digit appears 10 times. So then, in these 100 consecutive numbers, each digit appears 20 times total. We are ignoring the hundreds digit right now. Let's ignore this 1, which appears in the hundreds place in all these 100 numbers. But the other digits, all the digits, they appear in the tens and the units place exactly 20 times in these 100 numbers. But there will be, for example, let's talk about 2. So then 102, 112, 122, 132, 142, so on and so forth. 2 is appearing in the units digits. Then there'll be 120, 121, 122, 123, 124. So now the 2s are appearing in the tens digit. This will also happen 10 times. This happens 10 times. This happens 10 times. But note that if I'm counting just the number of numbers in which there is a 2, then 122 appears in both these lists because 2 is appearing in tens place as well as in units place in 122. So 122 has been counted in both the lists, and that is why the number of numbers with 2 in them, let's say number of numbers with 2 is going to be 19. But how many times does the 2 appear in the tens and the units place? That is going to be 20, this plus this. Right? Now, in 100 consecutive numbers, in the hundreds place, if you're talking about, let's say starting from 100 to 199 or 200 to 299, the hundreds digit will be the same. So in those 100 consecutive numbers, 1 will appear in all the digits. Then in 200 to 299, 2 will appear in the hundreds place in all the digits, and so on. Right? So that is the logic. So remember, what does help us in questions is to remember that in 100 consecutive numbers, a digit appears 20 times in 19 numbers. In one of the numbers, it appears twice. Yeah. Zero is different, so let's not include that for the time being, because let's say if we're talking about the hundreds digit and we're talking about 3-digit numbers, then zero cannot appear in the hundredth digit. So we'll look at it a little separately. So how many 3-digit numbers have either 2 or 0 in them? Now, first of all, how many 3-digit numbers have a 2 in them? So the 3-digit numbers, first of all, the first thing that comes to mind is all the numbers from 200 to 299, which means the 100 numbers over here, they'll have a 2 in them for sure, because they already have a 2 in the hundreds place. So these 100 numbers have a 2 in them. So we have counted them. We'll not count them again. Let's put them on the side. Let's look at the other numbers now. We're talking about 3-digit numbers. So let's say we talk about from 100 to 199. Now, how many numbers will have a 2 in them? We know that 19 numbers will have a 2 in them. We just discussed it over here. So 19 numbers will have a 2 in them in 100 to 199. 19 numbers will have a 2 in them in 300 to 399. 19 numbers will have a 2 in them in 400 to 499, and so on and so forth till 900 to 999. So for 8 of these ranges, we have removed the 200 to 299 out of this, right? In 8 of these ranges, we'll have 19 numbers with a 2 in them. So then total number of numbers with a 2 in them are going to be 100 plus 19 into 8, yeah, which is 152, and plus 100, that is equal to 252. So total 252 numbers will have a 2 in them. Now, what about how many numbers will have a 0 in them? So since we're talking about the numbers from 100 to 999, all the 3-digit numbers, 0 will not appear in the hundreds place. It will only appear in the tens and the units place. Now, in 9 of these ranges from 100 to 199, from 200 to 299, so on and so forth, from 900 to 999, each of these ranges will have exactly 19 numbers with a 0 in them. Because when we're talking about 0 in the units place and in the tens place in 3-digit numbers, then it acts just like any other digit. Look over here. See that it appears exactly once in every 10 consecutive digits. It appears exactly once in every 10 consecutive digits. And same happens for the tens digit also. It appears 10 times. So that is why it uses the same logic over here. So in all these 9 ranges, the 0 appears 19 times, which means that it appears a total of 19 into 9, which is 171 times. So the 0 appears in 171 numbers and the 2 appears in 252 numbers. Now we need the 3-digit numbers that have either a 0 or a 2 in them. What does it mean? That we cannot double count. There are some numbers which are going to be here as well as over here. We should not double count them. Okay, so then how many such numbers are there which we have double counted? Let's think of that. First of all the numbers of the range, the 19 numbers lying in the range from 200 to 299, which have a 0 in them as well, have been double counted. We know that, right? Because they already have a 2 in the hundreds place. We have already counted them in 252, so we should not count them over here. So we need to remove these numbers out because we have double counted them. Now think of another range, for example, 100 to 199. how many numbers have been counted in both 171 and in 252. That is, how many numbers here have a 0 as well as a 2. Well, there are only two such numbers, isn't it? What are those two numbers? It will be 120 and 102. Because these numbers, they have 1 in the hundreds place. They must have a 2 and a 0 as well. And so there are only two ways in which we can write this number. What will happen if we have 300 to 399? Again, there'll be two such numbers. There'll be 302 and 320, and so on and so forth. So in all these ranges, in all the rest of the ranges, the 8 ranges, there'll be exactly two numbers which would have been double counted. So that is why we'll need to remove these 8 into 2, that is equal to 16 numbers as well. And these are all the numbers that have both 0 as well as 2 in them. So the total number of numbers is going to be 252 plus 171 minus 19 and minus 16. So this is minus 35, and this gives us 2 and 12, and okay, so this gives us 388. So there'll be 388 numbers which have either a 2 or a 0 in them. Note that how many numbers have a 2 in them and how many times do we need to write a 2 are two different questions. So in the first case, we count the number only once, even if it has multiple 2's in it. Whereas in the second case, we count every instance of the 2 that we write.